So we have the double angle identities. Sine of 2x is equal to this. Cosine of 2x, the main one that we use is this one, but these are the three different ways that you can write it. They're all equivalent. And then tangent of 2x is equal to this. Those are our double angle identities. We also learned the sum and difference identities, which are listed here. So these are all in your notes for you. Let's verify this identity using these different ones that we've learned. So I'm only going to manipulate one side of the equation. I'm going to manipulate the left side. So this looks like a difference one. Sine of a minus b is what I'm going to use here. So I'm going to use this identity for this problem. So using that identity, I know I'm going to do sine of a, which is x, cosine of b, which is pi over 6, minus sine of pi over 6, cosine of x. Using your knowledge of the unit circle, this is my unit circle. Pi over 6 is right here. And the coordinate, what are the coordinates at pi over 6? Square root of 3 over 2 and 1/2. So this is the value of cosine at pi over 6. And this is the value of sine at pi over 6. So instead of writing cosine pi over 6, I can write square root of 3 over 2 times sine x. Minus sine at pi over 6 is just 1/2 times cosine x. Do you guys notice that the denominators are both 2? I can put this in the numerator. I can put the 1 and cosine x in the numerator. My denominators are the same, so I'm going to combine these fractions. If I combine the fraction, I'll have 2 in the denominator. I have this, sine x square root of 3, minus this, cosine x. And that's what I have here. With multiplication, it doesn't matter if you say 1 times 2 or 2 times 1. So I can put the square root of 3 first. It means the same thing as this. So I'll just reverse it so it looks identical. There we go. So this matches this. So that is how we verified using the different identities that we've learned. Let's try another one. This is another difference one. Here's the formula. Cosine of a minus b is cosine a cosine b plus sine a sine b. These are opposites for cosine. Okay, so in this example, this is my A, this is my B. So I'll do cosine of A, cosine of B, plus sine of A, sine of B. Remember, whenever we're verifying the identity, we're only changing one side of the equation. So I'm only working on the left side here. It doesn't matter which side you pick. I picked the left side. Okay. So using your knowledge of the unit circle. Right here is pi. What's the coordinate at pi? -1, 0. So cosine of pi is -1. Sine at pi is 0. So that means this is -1. This is 0. -1 times cosine is just negative cosine. 0 times sine is just 0. So you're just left with negative cosine x. And that's what we have over here. So that is verified. You need to show every step. I need to be able to follow your work. So if you want credit for your answer, you need to show every step. I need to be able to follow it. Next one. So yes, a tip is to change things to sine and cosine. So I'm going to do cosine x over sine x. I'm changing cotangent. And I'm going to change tangent to sine over cosine. You need to show every step. You can't just jump over steps. Okay, now I'm going to combine these fractions. In order to combine fractions, what do I need? Yes, I need the same denominator. So I'm going to put a cosine x here, and I need to also do it to the numerator. And on this one, I'm going to put a sine. Now they both match. They both have sine, cosine, sine, cosine. So what I have is 1/2. My denominators are the same, so it'll be sine x cosine x. My numerator, cosine times cosine, that's cosine squared, minus sine and sine is sine squared. Notice how I'm showing my steps. I did not jump from here straight to here. I need to be able to follow the process. Okay, now we're gonna do some identities. Let me give you some reminders. Cosine of 2x is what? There you go. That's an identity. And what was this one? Sine 2x is what? Good, guys. So I'm going to use these identities. Notice, if I multiply this inside, 1 times the top, it just stays the same. 2 times this is just 2, all of that. So I'm just going to go ahead and distribute that in, and you'll be able to see it better. When I multiply in 1/2, this will just be cosine squared x minus sine squared x over 2 sine x cosine x. Now, guys, look, I'm going to use my identities. In the numerator, I have this. That's cosine 2x. In the denominator, I have this. I'm going to replace it with sine 2x. We're using the identities to solve, to verify. Okay, so what is cosine over sine? Cotangent. So this is equal to cotangent 2x, which is what I have on this side. So we just verified that this statement is true. This identity is true. Now we're going to solve equations using these identities. Remember my piece of advice, turn things into sines and cosines if you can, and also use identities. So notice, guys, tangent is just sine over cosine, and this is an identity that you know. Sine of 2 theta is just 2 sine theta cosine theta. So let's use those identities. I'm going to write this as, I have a 2. Tangent can be written as sine over cosine. Sine 2 theta can be written as 2 sine theta cosine theta equals 1. We're only changing one side of the equation. Now, great, things are going to cancel out. Cosine cancels out with cosine. What I am left with, 2 times 2 is 4. Sine times sine is sine squared theta equals 1. Let's continue solving. I'm going to divide by 4. on both sides. And then what? Square root, both sides. Square root cancels out with the squared. I am left with sine theta is equal to the square root of 1 is 1 and the square root of 4 is 2, plus or minus. Because -2 times -2 will also give you 4. Okay, so plus or minus 1/2. All right, so guys, answer me this. Where is sine 1/2? What degree? 30, good. So at 30 degrees, if I plug in a 30 degrees here, sine at 30 degrees will give me 1/2. What else? 150. And we also have -1/2, so what else? Yep, 210 and 330. So yep, those are my degrees that will give you 1/2 if you plug it into sine. So those are my answer choices. And all of these degrees are within the interval. They're within 0 and 360. Solving this one, do you guys recognize an identity? On the right side, what is this? Yes, this whole thing is just equal to 1. That's an identity. So I'm going to write this again. 2 sine of 3 theta is equal to 1. Now let's just keep solving. I'm going to divide both sides by 2. So now I have sine of 3 theta is equal to 1/2. Now again, guys, whatever this is, when you plug it in, it needs to give you 1/2. Where is sine 1/2? 30 degrees, where else? 150, just positive 1/2. Okay, so only at 30 degrees and 150 degrees. So that means whatever this is, when you plug it in, it has to give you 1/2. Okay, so let's go ahead and solve for theta so I can see the exact value. I'm going to divide these by 3. So I know that theta is 30 divided by 3 is 10 degrees, and 150 divided by 3 is 50 degrees. All right, so guys, just look real quick. If I plug 10 degrees into my problem, 3 times 10 is 30. Sine of 30 degrees is 1/2. If I plug 50 degrees into my problem, I'll get 150. Sine at 150 is also 1/2. You guys see how that worked? Okay, however, guys, I'm going to have more solutions than just this. I'm going to have more solutions. So, guys, let's do another spin around the circle. Can you guys add 360 to that? Let's add 360. Add 360. I'll have 390 degrees. And what's 360 plus 150? 510. Okay, and guys, we're going to divide these by 3. It would help if you grab your calculator. We're going to be doing a lot. All right, so if you divide these, you'll get 130 degrees. And what's this one? 170 degrees. Okay, I think I can get some more within this interval. Let's do another lap. So let's add 360 to here, 360 to here. Let me know what I get, guys. What's 390 plus 360? 7 what? 750. Divide that by 3. You got 250. Thank you. And 510 plus 360? 870. And then divide it by 3. 290. Okay, I'm just going to let you know that's the last solution. You guys see how all of these are within 360? Okay, let's just test it. I'm gonna plug 290 into here. What's 290 times 3? 870 degrees. And that is equal to 1/2. That's right here, I believe. If you subtract 360 a whole bunch of times, will you end up right here at 150? Perfect. So you got 1/2. So all of these are your solutions. Let me show you a shortcut. You see this number right here? It's a 3. Multiply this by 3. Whatever that is, you're going to have that many rotations. Okay? So if you thought of this as 0 to 2 pi, you have a 3 right here. So multiply it by 3, you'll get 0 to 6 pi. How many rotations is that? That's 3 rotations. That's 3 laps. So we did 1 lap, 2 laps, 3 laps. Whatever this number is, you multiply by 2. That's how many laps you're going to have. Let's talk about it. So before I get started, let's just think about regular sine x equaling square root of 3 over 2. If you think about the unit circle, that is right here and right here. What is this? 60 degrees and 120 degrees. Okay, so how many solutions is that? Yep, there's 2 solutions. Well, because I'm not counting the negative ones. I just want positive square root of 3 over 2. So 2 solutions within this interval, correct? Okay, now in this one, I have 2x. So we're going to multiply this by 2. So this is going to be 0 and 4 pi. So in this one, they did one revolution. Here is 2 revolutions. So that means they're going to pick up another 2 solutions. So this is 4 solutions. This is a 3. So now your interval is 0 to 6 pi. That's 3 laps. They're going to pick up another 2 solutions. This is going to be 6 solutions. Each lap, there's 2 solutions, remember? This is 4. So this is going to be 0 to 8 pi. That's 4 laps. There's 2 solutions in each lap. This is 8 solutions. Now the proper term is not laps, revolutions, right? Okay. So basically, guys, what do you do every time? How do you know how many solutions you're going to have? Yep. So whatever it is, you multiply it by 2. So 2n. So if you have sine of n theta, you do 2 times n. Whatever this is, you multiply it by 2. That's how many solutions you'll have.